Techniques by physical state of mobile phase. Gas chromatography. Gas chromatography, also sometimes known as gas-liquid chromatography, is a separation technique in which the mobile phase is a gas. Gas chromatographic separation is always carried out in a column, which is typically packed or capillary. Packed columns are the routine workhorses of gas chromatography, being cheaper and easier to use and often giving adequate performance. Capillary columns generally give far superior resolution and, although more expensive, are becoming widely used, especially for complex mixtures. Further, capillary columns can be split into three classes: porous layer open tubular, wall-coated open tubular, and support-coated open tubular columns. Plot columns are unique in a way that the stationary phase is adsorbed to the column walls, while WCOT columns have a stationary phase that is chemically bonded to the walls. Scott columns are in a way the combination of the two types mentioned, in a way that they have support particles adhered to column walls, but those particles have liquid phase chemically bonded onto them. Both types of column are made from non-adsorbent and chemically inert materials. Stainless steel and glass are the usual materials for packed columns, and quartz or fused silica for capillary columns. Gas chromatography is based on a partition equilibrium of analyte between a solid or viscous liquid stationary phase and a mobile gas. The stationary phase is adhered to the inside of a small diameter glass or fused silica tube, or a solid matrix inside a larger metal tube. It is widely used in analytical chemistry, though the high temperatures used in GC make it unsuitable for high molecular weight biopolymers or proteins, frequently encountered in biochemistry. It is well suited for use in the petrochemical, environmental monitoring and remediation, and industrial chemical fields. It is also used extensively in chemistry research. Liquid chromatography. Liquid chromatography is a separation technique in which the mobile phase is a liquid. It can be carried out either in a column or a plane. Present-day liquid chromatography that generally utilizes very small packing particles and a relatively high pressure is referred to as high-performance liquid chromatography. In HPLC, the sample is forced by a liquid at high pressure through a column that is packed with a stationary phase composed of irregularly or spherically shaped particles, a porous monolithic layer, or a porous membrane. Monoliths are sponge-like chromatographic media, and are made up of an unending block of organic or inorganic parts. HPLC is historically divided into two different subclasses based on the polarity of the mobile and stationary phases. Methods in which the stationary phase is more polar than the mobile phase are termed normal phase liquid chromatography, and the opposite is termed reversed phase liquid chromatography. Supercritical fluid chromatography. Supercritical fluid chromatography is a separation technique in which the mobile phase is a fluid above and relatively close to its critical temperature and pressure. Affinity chromatography. Affinity chromatography is based on selective non-covalent interaction between an analyte and specific molecules. It is very specific, but not very robust. It is often used in biochemistry in the purification of proteins bound to tags. These fusion proteins are labeled with compounds such as His tags, biotin or antigens, which bind to the stationary phase specifically. After purification, these tags are usually removed and the pure protein is obtained. Affinity chromatography often utilizes a biomolecule's affinity for the cations of a metal. Columns are often manually prepared and could be designed specifically for the proteins of interest. Traditional affinity columns are used as a preparative step to flush out unwanted biomolecules, or as a primary step in analyzing a protein with unknown physical properties. However, liquid chromatography techniques exist that do utilize affinity chromatography properties. Immobilized metal affinity chromatography is useful to separate the aforementioned molecules based on the relative affinity for the metal. Often these columns can be loaded with different metals to create a column with a targeted affinity.